everyone, welcome to homework 2.12. I am going to go over, this date is wrong, sorry about that. I'm going to go over the homework and then I'm going to go back and look at the last classwork section. So a parking garage charges $5 for the first hour, $10 for up to 2 hours, and $12 for the entire day. Let G be the cost of parking for T hours. Complete the table. So sketch a graph of 0 to 12. So we're looking at from 0 hours to 12 hours. What would it be? So if we are parking for 0 hours, it's going to cost us $0. If if I park for half an hour, then that is going to be $5. 1 hour will be $5. And then when I get past that first hour and I'm getting up to 2 hours, then it's going to be $10. And then when I get to 5 hours, after that, it's going to be $12 for the rest of the day. All right, so I'm first going to be looking at 0, 0, right? That's how much it's going to cost if I don't park at all. And then from that point on, after 0, up until 1 hour, it's going to be $5. So that is going to be including this point up into here, okay? Now, then next after that, I'm going to be looking from 1 hour to 2 hours. At 1 hour, it's going to cost me $5. So at that specific point, it's going to be an open circle at the $10 mark. Oh, I'm sorry, I put this at the wrong place. Let me do that again. $5 rather, is here. There you go. And going across to 1 hour is here, okay, for the first hour. Then it's $10 for up to 2 hours. So $10, open circle here, because it's still $10 at 1 hour, up to 2 hours. Then it is $12 for the entire day. So after that point, it's going to be $12. Okay, and including this point there. It says, is G a function of T? So is the cost a function of time? Yes, because the time is the input, and for every x value, there is one corresponding y value. Is G a function of T? No. Or sorry, yeah, is T a function of G? So is time a function of cost? No, because for each cost, there is more than one time frame, right? So the reason this is time, G is a function of time, works is because for every input of time, there is an output, right? However, for every output, right, or for every cost, I could have multiple values that would be the number of hours it would produce, or that it would be for that cost. All right, is this graph a function? Explain your reasoning. So here, if we go through the vertical line test, we can see that this crosses through 2 points here, crosses through 2 points there. So no, because of vertical line test. And also for the x value of 2, there is a y value of both 1 and 2 comma, it looks like 7. And for the x value of 6, we have 6 comma 3 and 6 comma 7. So this is not, oh, that's not a comma. Fix that. That is not a function. Number 3, use the graph of function G to answer these questions. So we're using this graph here. What are the values of G, comma, or g of 1. So when my input is 1, this would be 2, this would be presumably 1 there. Then it looks like I have an output here of 4. So g of 1 equals 4. G of negative 12 equals, looks like there, so negative 10. So g of negative 12 equals negative 10. And then g of 15, which would be here. Let's see, this is, they're going by 4, so this would be 16 here. So g of 15 actually doesn't look like, because this is an open circle here, so it doesn't look like that there is actually an answer of g of 15. And so g of 15 equals no answer set, because it's an open circle, and we can see it based on here, it's less than 15. All right, so what values of g of x is negative 6? So we get y equals negative 6. Let's look. Y equals negative 6 is here, and so that's where x is less than 1 and greater than or equal to negative 8. So between negative 8 and 1 is where x, for those x values, we get a y of negative 6. All right, now we're going to fill in the rest of the table. So between negative 8 and 10, so that's between here and here, y equals negative 8. Negative 6 is, we did that right here, so between negative 8 and negative 1, this is a y value of negative 6. Between negative 1 and positive 1, we have approximately a value of positive 2. That would be right there on the y-axis. And then for 4, when we have 4, that's between 1 and 10. And then our last one, from 10 to 15, we have a y value of 8. So again, this part gives us our inputs, and this part gives us our outputs. All right, this graph represents Andre's distance from his bicycle as he walks in a park. So this part's a bit of a review, but it's also a piecewise function because we have different things changing at different times. So for which intervals of time is the value of function decreasing or going down? Well, from here to here, so where x is less than or equal to 10, and greater than or equal to 5, 6, 7, 8, 9. Oh, sorry, 9 and 11, it looks like more like. All right. And then actually, let me go ahead and write this in interval notation. All right, so from 9 to 11, it is decreasing. And then again from here, which would be 14 and a half maybe, to 15, 16, 17. And then again from this point, so that's 21, to, we get to there is 26, 27. All right, for which intervals is it increasing? So now we're looking at the opposite areas here. So our increasing is going to be from 0 to 9. And then it's increasing again from here to here. So that is, oh goodness, let me change that back to pen. 17 to 21 is the places that it's increasing. Let me fix my notation because that looks too curvy. There we go. All right. Describe what Andre is doing during the time when the value of the function is increasing. So when the value of the function is increasing, right, this is the distance in feet away from his bike. So when it's increasing, he's moving away from his bike. All right, the temperature was recorded at several times during the day in this graph here. Function T, temperature, gives the temperature in degrees Fahrenheit N since midnight. So the input is the time of day since midnight, and here is that graph. Describe the overall trend of temperature throughout the day. So we're going to say, right, this is where we say from midnight to maybe that's 5. So here would be 7.5. So from midnight until a little after 5. The temp decreased, then increased until, all right, so when we get here, that's about here, we'll say 15, maybe at hour 16. So until 4 p.m., and then it's going to decrease again. Okay. It says, based on the graph, did the temperature change more quickly between 10 a.m. and noon? So we're looking from 10 a.m., so from here to noon. So that would be like here. Maybe a little till there, actually. From there to noon, or between 8 p.m. and 10 p.m. So 8 p.m. would be from 20 to 22 hours 22. So it would be from here to here, approximately. So which one are we seeing a greater change in? All right, so both of those are increments of 2 hours. So our denominator, it would be 10 or 12 minus 10, which is 2, or 10 minus 8, which is 2. So this is the first range, and then this is the second range. And then we're looking at a temperature here of about, we'll say 61, minus earlier, let me erase this so I can see a little bit better. There we go. All right, so that's, I said from 10, so here is about, we'll say 51. And then in this case, we're looking at our later temperature is 50 minus our earlier temperature is about, we'll say this would be 65, so this would be maybe 63. And so we're looking at 10 over 2 compared with negative 7 over 2. So this would be the greater change. And so from 10 to noon, because the average rate of change is greater. Right, and so we're using that same old formula, y sub 2, the later y minus the earlier y over x sub 2 minus x sub 1, or you can think of it as f of b minus f of a all over b minus a. But in either case, we're looking at the later value compared with the earlier value. All right, let's take a quick peek back at our last part of the classwork. So this says function C represents the dollar cost of renting a bike from a bike sharing service for T minutes. So here's our minutes. Here are the rules. And then it is telling us that we need to complete the table given the lengths. So if we're doing 0 minutes, it's going to be $0. If we do 10 minutes, then looking at this, 10 minutes is going to fall in this first range, so that's $2.50. 25 will be $2.50. 60 minutes now is getting into this range right here, and it's less than or equal to 60, so that would be $5. 75 minutes is above that, so that's $7.50. 130 minutes falls in this range here, so that's $12.50. And then 180 falls in this range, which is 15. All right, so we're going to sketch the function of the graph. At 0, it costs $0, right? At Anything after that, though, it's going to cost $2.50. So from 0 until we get to 30 minutes, and including 30 minutes, so it's going to be filled in, it's going to be $2.50. Then from 30 minutes to 60 minutes, it's going to be $5. So open circle on the 30, closed circle on the 60, and going to be $5. Then from 60 to 90, it's going to be $7.50, and again open on this side and closed on this side. And then from 120 to 150, oh sorry, I skipped one. From 90 to 120, open on this side, closed on this side, it's $10. Then it's $12.50 from 120 to 150, and then from 150 to 720. So after that period of time, it's always going to be 15. So this is going to continue to extend for the rest of the day. It would be $15. Describe in words the pricing rules for renting a bike from this bike sharing service. So we can see that every 30 minutes, right? Every 30 minutes it goes up $2.50. So it is $2.50 per 30 minutes for up to, and so that's up to and including 150 minutes. Okay, so up to and including 150 minutes.
Good afternoon, Jefferson Middle School Academy, please.
Okay, sorry about that. So for up to including 150 minutes, and after that is $15 for up to 720 minutes. Okay, determine the domain and range of this function. So the domain is from 0 to, based on this here, 720. And actually it's less than 720 because it just said it does not include that. And then, so that's the domain. And again, you can put that as an interval. And then the range is going from 0 to $15. So y will be less than or equal to 15 and greater than or equal to 0. So you can pay anywhere up to 0 to 0 if you don't do it, right? To $15. Okay. Your code word for today is scotch. Scotch, because you keep asking me for scotch tape. So happy homeworking and see you tomorrow.